Hi students, in this class we will learn about total internal reflection. First we will discuss about critical angle, then critical angle calculations, total internal reflection, conditions for total internal reflection and few applications and finally summary. What do you mean by critical angle? If you look at this diagram, you can see the incident light ray falls from water to the air. That means the incident light ray is from a denser medium to a rarer medium. Theta 1 is the angle of incidence and theta 2 is the angle of refraction. We know that when a ray of light passes from a denser medium to a rarer medium, the refracted ray will bend away from the normal. This is the surface of separation between the two medium. When this refracted ray just grazes this surface of separation, you will call this incident angle as the critical angle. Critical angle is represented by the letter C. At critical angle, this is the refracted ray. This angle is 90 degree. The angle of incidence in the denser medium at which the refracted ray just grazes the surface of separation is called critical angle. According to Snell's law, n1 sin theta 1 is equal to n2 sin theta 2, where n1 is the refractive index of the medium 1 and n2 is the refractive index of medium 2. Theta 1 is the angle of incidence and theta 2 is the angle of refraction. When you increase this angle of incidence at some particular value, this refracted ray just grazes this surface of separation. That particular value of the angle of incidence is called critical angle. At critical angle, when the angle of incidence becomes the critical angle, then the angle of refraction will be 90 degree. When theta 2 becomes 90 degree, theta 1, the incident angle becomes critical angle theta C. Now we can write n1 sin theta C is equal to n2 sin 90. What is the value of sin 90? Sin 90 is equal to 1. Therefore, this expression becomes n1 sin theta C is equal to n2 and sin theta C is equal to n2 by n1. If the light ray is emerging into air, the incident light ray is from water and it is emerging to air. In air, the refractive index is 1. Therefore, the expression sin theta C is equal to n2 by n1 becomes sin theta C is equal to 1 by n1 because we are substituting the value of n2 as 1. If sin theta C is equal to 1 by n1, what is n1 from that? n1 is equal to 1 by sin theta C. What is total internal reflection? If you look at this diagram, you can see three incident light rays. One is shown in light green color, the other one in red color, and this incident ray is in blue color. Look at the refracted rays now. The green color incident light ray is refracted in this manner with an angle of refraction theta 2. This red color incident ray is refracted in this way. The angle of refraction here it is 90 degree and this angle is known as critical angle. But if you increase the angle of incidence greater than this critical angle, what happens? In that case, instead of refraction, the entire ray is reflected back to the same medium. This is the reflected ray and this is known as total internal reflection. That is, if angle of incidence I is increased further, refraction is not possible and the incident ray is totally reflected into the same medium. This is called total internal reflection. What are the conditions for total internal reflection? The first condition is that the light must travel from a denser medium to a rarer medium. Here, the light ray passes from water to air. The light ray must pass from a denser medium to a rarer medium, either from glass to air or from water to air, etc. The angle of incidence inside the denser medium must be greater than the critical angle. This is the second condition. At critical angle, we know the refracted ray just grazes the surface of separation. If you increase this angle of incidence greater than the critical angle, then total internal reflection occurs. Instead of refraction, the entire ray is reflected back to the same medium. Let us now look into some of its applications. Total internal reflection is the main cause of the brilliance of diamond. Optical fibers use total internal reflection to carry light and information. They are used in telecommunication cables and in image forming fiberscopes such as colonoscopes. This phenomenon of total internal reflection is used in many optical instruments like telescopes, microscopes, binoculars, spectroscopes, periscopes, etc. In this class, we learned about the critical angle. What is critical angle? Critical angle is defined as the angle of incidence that provides an angle of refraction of 90 degrees. Then we learned about critical angle calculations. Sin theta c is equal to n2 by n1. And if the light ray is emerging into air, n2 value is 1. Therefore, sin theta c becomes sin theta c is equal to 1 by n1. What is total internal reflection? It is a phenomenon that occurs at the boundary between two mediums such that if the incident angle in the first medium is greater than the critical angle, then all the light is reflected back into that medium. The conditions for total internal reflections to take place are: light must travel from a denser medium to a rarer medium. And the second condition is that the angle of incidence in the denser medium must be greater than the critical angle. Finally, we discuss some of the applications of this total internal reflection. Optical fibers uses this total internal reflection property. In the diamond, the brilliance is due to this total internal reflection. It is also used in many other optical instruments such as telescopes, binoculars, etc. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.